Hey class, so I wanted to make a really quick video on quadrantal angles. So with quadrantal angles, and really with any angle theta, we can find out how much it's rotated around the xy plane by just dividing it by 2 pi. So if you take some random angle, like pi over 2, and you divide this by 2 pi, I shouldn't call this theta, but whatever. Pi over 2 divided by 2 pi will be 0.25. So this is saying it goes a fourth around the circle, and a fourth is just the positive y-axis. In fact, if you do this for any radian measured angle, you will get 0.25, 1.25, 2.25, and so on, right? All these angles are just, this one's going around, it's still on its first trip around the circle. This one's made it around once, this one's made it around twice, and so on. And this is true for our negative x-axis angles. These are going to have values of 0.5, 1.5, and so on. And then our negative y-axes are going to be 0.75, 1.75, etc. Whereas the positive x-axis is going to be 0, because you can't have a 0-degree angle, right? And 1, 2, 3, ... So this kind of flips when you have a negative angle, so you have to be careful of that. If I have, for example, theta is equal to negative pi over 2 divided by 2 pi. This will also give us 0.25. However, this 0.25 is negative, so it's saying it's only made it a fourth around going clockwise. So the negative angles are going to be minus 0.25, minus 1.25, and so on for the negative y-axis. It'll stay the same for the negative x-axis, and the positive y-axis will swap with the negative y-axis, negative 1.75, and so on. So for example, in my math lab, when it asks where does theta equal 3 pi lie, just divide that by 2 pi. Just say, okay, well, what is 3 pi divided by 2 pi? This is approximately, and approximately, it is 1.5. So that means that this lies on the positive, or sorry, not positive, negative x-axis. So, hope that helps out with this homework. I'll check to see if there's anything else, but if not, that's it for this video, and I'll see you next time. Okay, there was one more thing. So remember, if I didn't say this in class, let's just say r is equal to 1. So this radius is equal to 1. So what does this mean? Remember that the radius is the hypotenuse of our coordinates x, y. So when r is equal to 1, that means that the sum of x squared plus y squared is equal to 1. Okay, why does that matter? Well, when we're dealing with quadrantal angles, we're only dealing with things, or with angles, whose terminal side is on one of the axes. So for example, if we have something like theta is 90 degrees, so this is 90 degrees. This is on the y-axis. Anything on the y-axis has some coordinate in the y and a 0 in the x. So this is 0. So because r is set to 1, if x is 0, then that means that 1 is equal to y squared, right? Just taking this for the positive y-axis. This is only this is only for the positive y-axis. So let me write that down. It's only for the positive y-axis. Y-axis. 1 is equal to y squared. Why? Because x is 0. So that means y is equal to the square root of 1, which is positive or negative, but since this is the positive y-axis, we want the positive coordinate. So our coordinate's going to be 0, 1. Now, if I ask you, then, what tangent of this angle is, tangent of 90 degrees, we use these coordinates 0 and 1 to find its value. So tangent is opposite over adjacent. And in this coordinate system, opposite is going to be y, and x is going to be adjacent. So we get 1 over 0. So this is undefined. Undefined. So when we're dealing with quadrantal angles, you can get undefined or 0, and that's because we're setting r equal to 1. So just remember that we're setting r equal to 1. So whatever axis we're on, I'll do another, or tell you another example. So this one right here, for 180 degrees, excuse me, this is going to be -1, 0. Because r is set to 1, so it can only be one distance away. And x is on its negative side of the axis, so it's going to be a negative value. And again, since it's on the x-axis, y is 0. So use these coordinate systems to evaluate your tangent functions, cosecants, and so on. Okay.